Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0686 indicates an issue with the AF sensor, specifically related to its heater power source circuit experiencing a short to ground. The AF sensor, also known as the air-fuel ratio sensor, plays a crucial role in monitoring the mixture of air and fuel entering the engine to optimize performance and emissions. This sensor is often located in the exhaust manifold, closely observing gases before they enter the catalytic converter. If the heater power circuit becomes shorted to ground, it can lead to incorrect readings from the AF sensor, causing potential engine performance issues and triggering the check engine light. Understanding the components involved and their locations is essential for effective troubleshooting and repair. Knowledge of the PGM-FI, Programmed Fuel Injection System, which controls fuel delivery and emissions, is also important. DTC P0686 signifies a malfunction in the AF sensor heater power supply circuit, indicating it has shorted to ground. The AF sensor is crucial as it ensures the appropriate air-fuel mixture for combustion, which directly affects vehicle performance and emissions. This sensor is typically located in the exhaust manifold, where it can accurately monitor the exhaust composition. A short to ground in the heater circuit leads to insufficient heating of the sensor, causing inaccurate readings that can trigger various engine performance issues. It is vital to approach this issue methodically, focusing on the AF sensor and its associated circuits to effectively identify and rectify the root cause. The potential causes of DTC P0686 include a short in the heater circuit of the A5 sensor, which directly affects its functionality. A faulty relay or fuse can also lead to insufficient power delivery to the sensor heater, resulting in a failure to operate correctly. Wiring problems, such as damaged or worn insulation, can create unintended connections to ground, triggering the DTC. Each of these possibilities affects the heater's performance, so thorough examinations of the wiring and components involved are essential during troubleshooting. Attention to detail will help isolate the specific issue causing the short to ground. The symptoms associated with DTC P0686 typically include illumination of the check engine light, which serves as an alert for the driver about occurring issues within the vehicle's engine management system. Additionally, drivers may experience poor engine performance, such as rough idling, stalling, or hesitation during acceleration. Increased emissions levels can also occur due to improper air-fuel mixture management, as the A-fuel sensor's readings are crucial for optimal combustion. Recognizing these symptoms early is important in preventing further engine damage and ensuring compliance with emissions regulations. Therefore, immediate attention to these signs is crucial for maintaining vehicle health. The first step in troubleshooting DTC P0686 involves problem verification. Start by turning the vehicle to the on mode, but do not start the engine. Use the Honda Diagnostics System HDS tool to clear any existing DTCs. After clearing, start the engine and recheck for any confirmed or pending DTCs. If DTC P0686 appears, it confirms the failure and indicates that further troubleshooting steps should be followed. If the DTC does not appear, there may be an intermittent failure, which requires examining connections and terminals at the relay circuit board, the AF sensor, and the powertrain control module, PCM. It is critical to diagnose based on these conditions to ensure a thorough and accurate approach. Step 2 entails checking fuse number A9, located within the underhood fuse and relay box. Turn the vehicle to the off lock mode before performing this check to avoid any electrical hazards. Inspect the fuse for continuity. A blown fuse indicates a failure in the circuit, potentially linked to the AF sensor heater. If the fuse is found to be defective, it is essential to repair any shorts in the associated wiring circuit. After repairs, replace the blown fuse to restore the proper functionality of the AF sensor heater circuit. Ignoring this important step could lead to recurring DTCs and persistent issues with the AF sensor performance. In this step, the relay circuit board must be removed and tested for functionality. The relay circuit board is crucial for controlling power distribution to components like the AF sensor heater. If upon testing, it is determined that the relay circuit board is faulty or damaged, it must be replaced promptly. An errant relay could contribute to the short circuit or power delivery issues, ultimately leading to the DTC being triggered. Verification through testing is vital, as a good relay board indicates the issue lies elsewhere in the circuit. The integrity of this component is paramount for maintaining the AF sensor heater's reliability. This step focuses on checking for shorted wires in the FI sub RLY out IGPS LAF line by disconnecting the AF sensor 1 6P connector. With the vehicle in off-lock mode and the relay circuit board removed, continuity must be checked between designated test points. Test point 1 is the corresponding pin at the relay board connector, and test point 2 is body ground. If continuity exists, a short in the wire between the relay circuit board and the AF sensor indicates a failure, requiring immediate repair of that wire. If there is no continuity, the wire is deemed intact, and further troubleshooting is needed to isolate the problem within other components. Continuing troubleshooting, jump the SCS line using the HDS and wait over 1 minute. Following this, disconnect the PCM connector number 1, 96P. Similar to previous steps, continuity needs to be checked between the designated test points, where test point 1 is the specific terminal on the PCM, and test point 2 is body ground. If continuity is found, it indicates a short in the AFHT wire, necessitating repairs between the PCM and the AF sensor. If testing reveals no continuity, the AFHT wire is likely intact. In such cases, consult authorized service information for similar DTCs or substitutions for the PCM to ensure it is functioning correctly. If so, replace the original unit. After completing the necessary repairs, it is vital to perform a final verification. Use the HDS to check for any remaining DTCs, specifically monitoring for DTC P0686. If no DTCs are indicated, this confirms a successful repair. To further ensure that the resolved issues are not recurring, a test drive of the vehicle should be conducted under various conditions to validate the integrity of the repair work. Closely observe any warning lights or symptoms that may appear during this process. This step is critical as it ensures that the AF sensor heater circuit functions as intended and that the vehicle operates smoothly. Preventive maintenance strategies are essential to avoid the future occurrence of DTC P0686. Regular inspection of the AF sensor and its associated wiring can help identify potential issues before they lead to faults. Maintaining wiring integrity is imperative. Ensure that the insulation is intact to prevent shorts caused by environmental factors or wear. Routinely monitoring the functionality of the AF sensor through diagnostic tools can aid in early identification of problems. Additionally, ensuring all connectors are secure can prevent intermittent failures that may not always trigger a DTC. By adopting these practices, you can prolong the lifespan of vehicle components and enhance overall performance. In summary, DTC P0686 highlights a significant issue with the A-FAT sensor heater circuit shorting to ground, which can lead to substantial engine performance problems. The importance of the A-FAT sensor in facilitating optimal air-fuel mixture cannot be overstated, as it directly impacts engine efficiency and emissions. Thorough troubleshooting, following systematic steps, is crucial for accurately diagnosing and repairing the root cause of the DTC. Each component involved, from fuses and relay circuit boards to wiring, plays a vital role in maintaining system integrity. Finally, adhering to preventive maintenance practices can greatly assist in avoiding future issues related to the air-fuel ratio sensor. Prioritizing these practices ensures the vehicle remains in optimal working condition. Please like and subscribe to the channel. See you next time.